And we're live. Welcome back, everyone, to another episode of Adventures in DevOps. And I have today no co-host, so I'm flying solo for the what looks like foreseeable future. So as consolation, I have a fact. There's a great white paper by Portainer talking about the operational overhead of Kubernetes. And so I'll link that in the talk description below after the episode so everyone can get at it. Basically, the TLDR is you're basically going to be spending an extra $1 million a year just because you decided to pick one orchestration platform over another one. More on that maybe later, but let's get to the point of the episode. And I'm really excited today to have Andrew Moreland, the co-founder of Chalk, with us. So welcome to the show.
Thanks, Warren. It's great to be here. And I have to say, I do agree. $1 million sounds about right.
It sounds like a lot of money, I think, but if you realize that's pretty much just 5 engineers, oh, wow, I actually totally get that. But I think a lot of people throw that under. And it's interesting because if I understand correctly, Chalk is a fairly recent company. Therefore, maybe it's okay to call it a startup. And I can wonder whether or not you've had to actually make a decision on whether or not Kubernetes would be part of the tech stack that you've decided to run with.
Yeah, so we do deploy on Kubernetes. And we can maybe talk about some of the details later. We run on Kubernetes clusters in our customer clouds. We did decide that it made sense to use. I think one of the things which pushed us in that direction is since we deploy into customer cloud accounts, we have to deal with multiple different kinds of clouds. So for us, Kubernetes is kind of a normalizing layer across, the specific details of like EC2 or GCE.
See, I think that's a really intelligent way of putting it, because a lot of times I hear we need to use Kubernetes because either we need to pad our resumes or more likely we want to be cloud agnostic, even though there's no business reason to do so. But what I heard is we actually have a business justification for being cloud agnostic. And you're doing the ridiculous thing of, if I've got this right, deploying to your customers' cloud environments directly. That doesn't sound like something I ever want to do.
Yeah, it wasn't something that we wanted to do initially either, or that we intended to do. We started out as effectively trying to present a hosted SaaS. So we wanted people to just come onto our website, kind of like Vercel or like any of the other platforms or service companies, click sign up and then like deploy their software and move on with their lives. But it turns out that when you work with more mature companies and you ask them for all their most sensitive data, like their PII, their medical records, their financial records, they don't really want to hand that to a random seed stage SaaS startup. So it's kind of mandatory for us to start processing data in our customer cloud accounts.
A pretty great justification. And we see the cost of paying cloud provider storage, and even transferring between one account to another one, increase over time as well. And so the ability to go into any sort of account and utilize the data where it is makes a lot of sense. Can I ask, what is Chalk doing where it becomes the competitive advantage to be deploying into your customer's environment?
Yeah, so the key thing that we do for our customers is help them process, transform, serve data to machine learning models. So we don't have specific opinions about the exact transformations they want to do or what their models are for. Oftentimes it's things like fraud or logistics or recommendation systems or search or something like that. But because these models tend to be really core to their business or to their risk and fraud functions, they process all the most sensitive things that they have. There's a few different dimensions in which being in the customer account matters. One is maybe the most obvious, which is that their data doesn't leave their account. When we talk to companies, we always talk to their infrastructure and compliance and security teams, and it gives those teams a lot of comfort to know that the data stays resident and that we don't actually have, we can't access it if they don't want us to. Say another maybe less obvious point is kind of what you touched on with the network transit. A, there's obviously no network transit, but B, it lowers the latency. So a lot of our customers care a lot about super low latency for these types of applications.
My understanding was, and this is having zero experience in either any sort of LLM data modeling or any sort of machine learning as far as it goes for the actual data, say something like fraud. I wouldn't imagine necessarily the PII would be relevant in the fraud detection. But again, like I said, not the expert here. So I can imagine it, the flip side. It may not be directly relevant, but super difficult to separate it out to be able to hand over only the relevant pieces.
Yeah, it's kind of, I would say both. So some of the companies we work with are literally about the PII. So like one customer, Socure, they're kind of their whole business is this particular set of PII actually the PII for a real person? If you look at their website, like their API not literally, but close enough, is basically post us and social security number, phone number, email address, and address, and we'll give you back a, yep, that's a person or not score. So as you can imagine, that's pretty sensitive.
Yeah, it's always interesting being in that position where it's almost like you don't know what the data is and you're in a way praying that it's not sensitive. But then you spin up an API where the answer is it sensitive data? And the answer, you're getting sensitive data in there for sure.
Yes. Yeah. It's almost like nuclear waste. You really don't want to have to process it, but particularly in fintech, you often can't avoid it.
Share with me here. If you're working with these fraud detection systems, you must know all the secrets on how to evade them then.
Well, I think part of the reason why we deploy into the cloud accounts is that I also don't get to see the code the customers are running. Oftentimes, I mean, we talk about it. We obviously are very hands on with the people we work with. One, I'd say ideally there is no way to evade these systems, and two, I don't get to know all the details of how they work. But I mean, there's some obvious things like probably anyone could intuit. Like it turns out identity theft does work. If you're using a real person's identity, it's a lot harder to detect that. It's kind of all the obvious things too. Like if you look at some of the other customers we work with, like Verisol, et cetera, just on the homepage of their website, they talk about device fingerprinting. So, people who are trying to commit fraud go to great lengths to try to avoid these systems, and that mostly involves pretending to be real people for very long periods of time so that they can kind of later on flip and become malicious.
There's a parallel to what we see in advanced persistent threats on digital systems where an attacker, lives off the resources for, I think it's up to 9 months is usually the average time before actually deciding to exfiltrate resources. And I think the other metric number is like 13 months, where people start throwing away the log data at that point. And so you don't even know what systems they had access to at that moment. I want to get back to the deploying into the customer accounts, though, because it's something that I said that I've always tried to avoid and never wanted to do, and you're doing it. And so this must have come with either some risks involved or some challenges as far as actually getting the technology to work. Like, it's not just so simple, like even in AWS, getting the access to the individual accounts, hand over with external account IDs or identifiers, IAM roles, et cetera.
I would say there's like a lot of things that are hard about it. Some are obvious, some are not obvious. The obvious ones are like, okay, how do you actually write down all the IAM permissions that your application needs? Like, who knows, right? So the answer was kind of like, well, let's scope it to 0, build a tool to automatically deploy it, and then just loop for days until we finally find the minimal set. But there's more subtle things too. Like, it turns out that in all these cloud platforms, there are global policies you can apply across all the accounts. And of course, like, really savvy infrastructure people are out there secretly saying things like, oh, you can't transitively assume IAM rules. But we have no way of knowing whether those policies are applied, and neither do the people we're working with at these companies. So that even if you control all the configuration right, you're still host. But there's all sorts of other things that go wrong too. You mentioned again earlier the network transit. It turns out that there's like a known problem between GCP US East 4 and AWS US East 1, for example. Like the network pipe there is just full. So it is understood and expected that you'll suffer packet loss over that pipe fairly often. And they actually have a whole product page, which I didn't expect to find, where you can buy a specific dedicated link on that pipe to guarantee yourself bandwidth. But basically, the cross-cloud stuff ends up being super wacky in these scenarios also.
That's actually really interesting you just brought it up, because Cloudflare just had a downtime that affected a whole bunch of customers. And I believe the same thing actually happened where it was about network congestion from Cloudflare to their US East 1 in Ashburn. And I'm like, I have no idea what's going on there. And you've said that, and it's like the second time in a month that I've heard about this, and now I start getting really concerned.
Oh, I think they're running out of internet in Virginia. It seems like the problem.
At this point, it's like, does that data center still exist? And I think the meme is for sure, like, why are you doing anything in US East 1? And the answer is because our customers are. And
exactly.
We don't have any choice.
Yeah, I have no choice, unfortunately.
Wow. Okay. The network going down was not top 3 of what I would have expected to have to deal with. As a startup, I mean, we're almost 10 years old now, and I still remember every single challenge we went through technically. Deploying to customer accounts, though, was definitely not one of those things on the list. But yeah, cross account IAM roles and service control policies. It used to be much worse, right? You used to get a deny and you had no idea in AWS. Now, at least it says, denied due to service control policy, and yes. You're good luck, getting that changed. But at least you know what you're trying to avoid there. How do you deal with expanding the footprint that you need in your customer environment? So if additional permissions are required, is it a manual process to get them to basically update something? Or I can't imagine what the workflow would be.
Yeah, it's not my favorite thing. It ends up being kind of a negotiation with every single customer. So I think fortunately these days, most of the IAM permissions are introspectable. Like, you can say, do I have this permission? And before you go and use it. So we try to write our software to do that sort of thing, and then present like warnings on the dashboard about, oh, we're missing some permissions. In general, it kind of means we can't use a lot of standard tooling. Like Terraform doesn't work really well in this workflow because, Terraform's kind of awkward if you want to automate it as part of a sign up button flow. B, Terraform really does not like not having permissions for things. You'll end up in situations where the DAG can't totally resolve, it can't even plan. So we end up having to build a lot of the functionality that you would normally get out of the box in Terraform for free, kind of in our own Go application, which does the orchestration of all these resources so that we can recover from missing permissions.
I don't want to understate that. It's just a simple thing like you write in some Terraform, or OpenTofu now, to update a resource. And the first thing you do is you try to go get that resource and you get it denied there. So even if you have update, like the ability to create that resource, there's a hidden get there that you may not have. And AWS or the other cloud providers do change over time. And so that one resource can become two resources.
Sure can.
And the OpenTofu, Terraform, whatever Pulumi provider will change to make the two gets. And all of a sudden you would start running into issues there. So yeah, I can totally imagine it's more of a feature flag flow where it's like, well, in order to get this feature, you have to first go through the security steps, and then we'll validate it on our side. And once it's been validated, then we'll actually enable it for you.
But I'd say maybe the other answer too is we've been trying to pull more things in-house over time. And in the beginning, we're a startup. We don't want to build everything top to bottom. We want to delegate to the best-in-class solutions where we can. As we have more resources and more experience and more opinions, we found that it's better to bring things like, log aggregation in-house rather than relying on CloudWatch or CloudTrail, whatever the Amazon product's called, or Stackdriver logging. We'd rather use ClickHouse logs or something like that, that we control so that we can make sure that it's a consistent experience and also kind of lower our permission footprint.
I can really understand that, especially if you're getting the logs directly out from the customer account. It's one thing if your AWS account or GCP account is creating logs in the log solution itself, but if they're being generated in somewhere that you don't control primarily, and then you have to then write some sort of funnel pipe to get from one place to another one, you're going to immediately start questioning, where do we want this data to end up, and then pay the least amount for it and have the most reasonable retention. In that regard, what's the onboarding process? Is it manual? Is it, do you take a white glove approach? Each of these customers, you said, much larger, they do care about their data in a lot of ways. It's not going to be probably self-sign up in a lot of scenarios.
Yeah, we are marching towards self-sign up, honestly, just to lower the operational burden of the white glove version. I don't think anybody really likes having a conversation about how to deploy software. So we would rather have a sign up form people can go through. Whether or not we actually make it publicly available is a separate question, because in some ways we're a remote code execution platform. So it is really challenging to make sure that our software is secure in an untrusted environment. But that aside, the way that we do it these days is we do a little handshake where we exchange IAM roles or things like that, maybe some private keys and public keys. And then we do work with people for kind of cookie cutter deployments. It's usually a couple hours. For more involved deployments, maybe across multiple cloud regions or cloud accounts or cloud providers even, that can be, 2-3 weeks to get stuff all the way rolled out and kind of certified for production.
When you inevitably get to the point where you've decided after many years of running your company that it's time to deploy a second version of whatever you had, how does that get to the customer environment?
In the beginning, when we thought we were going to be like the Vercel for data, and to today, we're more enterprisey. We used to just publish releases and people would pick them up kind of automatically. But it turns out, again, large enterprises don't really like surprise software updates for lots of reasons, both, maybe we make a mistake, maybe we make a change that they don't like, maybe we make an improvement that they don't want. So we publish versioned releases of our software now, and we do ask that customers, basically choose which version they'd like to execute. Obviously that has all the downsides of version software releases, i.e. my mistakes live forever.
Yeah, so you have some Helm charts or something that the customer is pulling in and running in their Kubernetes environment.
Yeah, we version the Helm charts for the full metadata plane deployments when people host that themselves. We version the underlying software, we version our SDKs, all those things.
Are there unexpected downsides here of going down this approach rather than, forced rollout or upgrades? Do you find that you're getting support scenarios for the older versions that are missing critical stuff?
Yeah, it's definitely a problem. I mean, what I always tell people is, I think my latest version is my best version, and it should have all of my newest and best things in it. So if people are not on it, then, I think that they're missing some stuff I think they should have. So we do run into issues where we fix bugs, we make improvements, and they're important. Like we add better load shedding, for instance. And if someone's running an old version that doesn't have the ability to like properly do dynamic rate limiting, they may run into a scenario where they get overwhelmed and end up having a latency, escalation. We do keep track of what versions people are running, and we do like our kind of solutions team works with them to make sure they're updating regularly. We don't really want people to be stuck on a year-old version forever.
Are there though?
I think we had one person who was running January software until about 4 weeks ago. But in general, most people are within 2 or 3 months.
That's pretty recent. Like even January, you've got the same year there, 2025, without any previous hiccups. I would say I'm a little surprised. I see a lot of companies running older versions of stuff that, like, we have open source SDKs for every language for our product, and I can guarantee you there are some that have never upgraded since the moment they deployed their original version. And those early customers of ours, that's almost 10 years ago. So that's kind of scary in some regard.
Yeah. No, I think that like the main way we try to like engineer for that is we make sure that like we have never intentionally made a backwards incompatible change. One day we may make a breaking change. We have made some mistakes in the API that we'd love to correct, but we really want to prioritize that upgrade experience. So we never ever intentionally break. Anytime a customer can't upgrade because of a regression, we make sure that's a P0 issue. So that's top of the heap for us in terms of triage.
I think I really like this perspective. I went into it a little bit earlier in one of our episodes in the Auth Showdown, where we were discussing multi-tenant versus single-tenant solutions. And one of the things that came up was like, can you manage backwards compatible like forever? And because we have a SaaS, that's actually what we really try to focus on doing, because I'm totally with you. It's so critical to be able to migrate from one version to another one. And I feel like one of the problems with like open source software, or you choose the version as a customer, is that there's less discipline involved from the company, right? If you can break things, and because you say, well, people don't have to upgrade, then you don't care about it. But you've taken a like really smart, mature approach there, which is, yes, it's not critical for any of our customers to do this, but it's so critical from us, and we know the pain that they're going to find at some point, that if they can't do the upgrade, it's something that we have to fix for sure.
Early moments in the company's history that kind of shaped this philosophy, in addition to just like our opinions, was we had a company churn to us from a competitor because they said, well, doing the upgrade for our competitor's software is approximately as hard as adopting a new solution, so we might as well do a competitive eval. And I was like, well, okay, we're never going to give anyone that opportunity.
So many different things that we think about in our product when it comes to our customers and trying to avoid it's mental challenge of the churn, right? I mean, even if they're not actually going to do it, having a customer tell you the exact reason that they're churning and be like, well, let's bake that into the future DNA is really something there. So before we got started on today's episode, there was a lot of technical problems, but many minutes of dealing with the current state of microphones and software. But one of the things you had mentioned that I completely glossed over, and I have to be honest, I never heard anyone say this before, was we deal with time travel in data. And I honestly have no idea. Like I know this idea of time travel, like replaying events from some sort of event stream. That's not exactly the model that you have to deal with.
Yeah, it's not totally dissimilar. So one of the things we think about a lot is bitemporal modeling, which is a really fancy way of saying that there's at least 2 timestamps you actually care about in data. One is, when did a thing happen? But the other thing is, when did you know that it happened? And that's a really important distinction to make when you're trying to train machine learning models, thinking about a fraud model. Someone commits fraud on your platform, maybe on like January 1st, but you don't actually find out that it was fraud until maybe 2 months later when they issue an ACH return at the end of the 60-day expiration window. So you did not know that it was fraud until, say, March. So when you're building your training sets to train your machine learning models, you need to be very careful to make sure that no information which you learned after the time of the decision leaks backwards into the effectively row of data which represents that event. Even though you have been collecting data during that whole window and learning new things, you need to make sure you filter it out. And that's not so hard if you have immutable data sources and simple relationships, but it gets really nasty when you're doing things like computing aggregations over transactions, or applying, complicated filters on statuses, which are evolving over time. So at the core of our software is effectively a SQL engine, but one of the ways in which it's different from most SQL engines is that it has this notion of the effective timestamp of every, cell of data in the system. So we can kind of manage that filtering for you.
If I'm doing some sort of machine learning, and in the data set that I'm using to train the model, I actually need to make sure I'm not including the sort of output of the model, which in a lot of ways is something you today with LLMs we actually want in there because we want it to actually affect the driver of the token selection on the output tokens. But if it's included in there, then the model sort of knows about that data, which will in effect defeat the whole purpose of the model, which is to figure out not knowing that. I mean, I can understand associations or matching that where you would want it, but when it comes to date-based things, I totally get that.
Can kind of apply the same logic to the LM applications too. Imagine like you present a transaction to, GPT-5 and you say like, is this fraud or not? It'd be really unfortunate if part of the information you gave it included the label is fraud or not. It would hopefully pick up on that label and say, well, it's in fact not fraud. So we know that a priori. That wouldn't be, in general, when people go and swipe credit cards at merchants, they don't actually tell the merchant whether they're committing fraud. So it's not super useful to train on that signal.
It does remind me of two scenarios in the recent history for the creation of LLMs and machine learning in general. The first one is the presence of the medical ruler in the detection of cancerous moles in dermatology. Like if the ruler is there, there's a problem, right?
Yeah.
And I think there's a generic base for this known as like the giraffe problem. Early on, is if you gave an image model a picture of a safari and said, is there a giraffe? The answer was always yes.
Because there always was.
Because it has not because there was ever a giraffe there. It was because if you ever asked if there was a giraffe, it was highly correlated with there actually being a giraffe. So therefore, the presence of the question eliminated the possibility of it being no. So as soon as the question was asked, there was always a giraffe, even if there wasn't one in the picture.
Yeah, it's the same sort of problem that we're trying to stop. It ends up being extremely painful and subtle because, you have database records that have timestamps on them, but it turns out in production systems, the timestamps are approximate or maybe someone else came along and updated the row and the original domain modeler didn't know about it or things like that. So I don't know, 20% of the time in the entire process of doing machine learning is about actually figuring out when things did happen and when you did really learn about them and would that information have been available.
If someone had the ridiculous idea to try to, go build time travel themselves and not rely on Chalk to solve this for them, like, is there some secret here? I mean, don't tell us everything, but something specific about how you're thinking about the problems in order to evade this potential issue in the output.
I think there's a couple of different dimensions we think about it at. One is like at the SDK layer when people are defining, how data is integrated into the system. We can kind of have things which encourage them to think about the distinctions between these types of timestamps. Then there's like the actual query execution layer. So inside of the system, which is doing things that are like SQL semantics, in a normal SQL database, you track tuples. We're tracking tuples augmented with a lot of metadata. So we know extra information, extra bits basically about every value we're moving around, which tells us when did it become effective, when did it become replaced, is this an actually valid value, is it null because it's missing? And we're making sure that all the operations we do kind of properly transform that metadata in addition to the source data. You would have to do something like that, I think, in order to build a replacement. And then the third thing is down at the actual physical execution layer. So we care a lot about making sure things run really fast. So we have to implement like custom join algorithms and custom, actually ways of adding numbers together so that we can respect all this metadata and do these operations efficiently. It turns out that just like if you just do straight standard SQL aggregations, you run into enormous cardinality explosions in the size of the data you're processing when you have to think about all the different time points it occurs at.
Just for clarity, the models, they're being built on your customer side based off of the data that you're providing, or are you helping to build the model?
Yeah, so we don't usually get involved in the actual model construction. We do oftentimes provide advice about how to model the data that's flowing through the system, like what schemas make sense. How should you think about time? Right now, we don't do any model training. Like we don't do any like solutions stuff for model training for people.
I think it's like immutable databases for machine learning.
Yeah, we call ourselves the data platform for AI and machine learning. We don't think it's specifically fraud related. Like we do recommendation systems, search, logistics models, a lot of content moderation, which is kind of fun. We basically think about, okay, what are all the workflows that are involved in actually productionizing AI or machine learning? And can we build like an end-to-end answer for that versus building horizontal infrastructure?
You found one of the magical shovels in this AI bubble.
Elliot and I both did effectively the job our customers do at a bunch of different companies before. So we saw a system like Chalk get built a bunch of times, and we've tried to, make an actually good version of it instead of the 4 engineers, 2 quarters version of it.
Having been in a similar circumstance, I find the challenge there is you shift from being a technical person, which it very much seems you are, into what I absolutely hate doing, which is marketing and sales, to try to convince people to buy the product that you already know they need. And you're nodding your head, which means you know exactly what I'm talking about.
I don't know if this is something we should say, but effectively we have a 100% pilot close rate, i.e. if you come and try our software, it is almost inevitable you will buy it. But of course, then the problem becomes, how do you get the word out? How do you get people to actually try it? So, here we are. It is interesting because I think it's really difficult to convey what we do and what problems we're solving. And I don't think we've really found the 2-sentence elevator pitch yet, despite thinking about it for 3 years.
I'd maybe give you some more confidence in your ability here. I do think you're clear about talking about what is going on there. And even at our point, which is, I don't know, I forget the exact year, how long we've been around. It's not even competitors. It's other companies that have used similar language and basically stolen it to mean something completely different. And now all that's left is either you compete with them and say the same things they're saying, but mean something totally different. The right thing, I'll say, not the wrong thing that they're peddling.
Of course,
or
yeah.
you say something completely different, and your customers are like, "We have no idea what you're talking about," and they, churn from your marketing page, or they don't even get there because they don't understand what you're actually going at. I'll say from experience, one of the secrets here, especially going after the larger enterprise customers, is it doesn't matter because you don't care about your marketing page. You care about, connecting directly with whoever is making the decision.
Right. Yeah. The old high touch sales.
Yeah, high touch sales. So you must love that.
Fortunately, both of my co-founders are much more charismatic than I am. So they focus mostly on the pre-sales stuff before people actually sign up to buy the software. And I get to think about the hard, interesting problems post-sales. But it's definitely a big challenge. And I think the kind of reason we constructed this company is because Elliot and I did a consumer fintech before, and that was 100% about marketing. If you don't love changing the background color of ad creative on Facebook Ads Console for your entire life, you shouldn't do consumer fintech. And we basically spent the time during our earnout at Credit Karma thinking about, okay, how can we make a company where we get paid money to solve interesting systems problems for, big companies? And this is what came up with.
You went down a third path there, if I understood your LinkedIn experience correctly. You made a great company and it got acquired.
Yeah, we built a consumer fintech company. We basically stapled a bank to an investment brokerage and then added, we call it self-driving finance, but that's, like you say, everyone says that now. Machine learning-based wealth management, which would do constraint solving to move money around automatically for you. And it turns out that the set of people who are really interested in personal finance, such that that sounds like a cool thing to them, and also who don't want to be involved in the management of the personal finance, is approximately the null set. Basically, everyone who cares about personal finance wants to manage it, and everyone who doesn't care about personal finance is not going to buy a fancy financial planning product. So the tech was cool. We grew the business. Eventually, Credit Karma bought the company because they wanted to offer that type of financial management, to the 100 million some odd people that they serve. I learned that I really don't enjoy doing consumer.
I had a slightly different takeaway there. I make a lot of mistakes with what to do with my personal finances, and that made me one time say, doing some hypothesis and guessing is going to be more of a better strategy. And so I threw some money at a product that automatically promises you returns by buying and selling shares of different index funds. And it wasn't the worst decision I ever made. I mean, I didn't put all my money there, but I definitely put some there. And so if you think you're good with money, just dispel that notion. You're definitely worse than just buying the index fund in most scenarios, but you can do a little bit better than that if you happen to find an engine that is willing to manage it. So being in that null set, that magic space where you know what you're doing, but also want to do the management and then just stop doing the management, it's like a form of delegation.
Yeah.
I like the pivot because you're doing something that seems like way more interesting than moving money around. I mean, I don't know. I'm saying that and I don't know anything about the technology on either of these pieces, so maybe that's a bit unfair. But I'm what you've shared so far is in a way really exciting because you're not talking about building AI, you're talking about your customers doing machine learning on a complexity set of data that they just wouldn't be able to achieve otherwise, and you're deploying your software into their accounts so that you can get access or integrate with their cloud provider where the data actually is and not do it yourself. I mean, you're avoiding a lot of complexity that didn't bring value, and you figure out a way to still, solve the real challenging problem, which you already experienced. I mean, I think you're onto something. And you said the company's only 3 years old now.
I would say that so far it's been interesting because you see the challenges coming, but maybe you choose to run into them anyways. So I think we've dodged a lot of the dumb things like messing up with fundraising, like how do you incorporate a company, like how do you do business ops, like accounting, all those things. Like we're good at that because we've all been through this before. But there are other challenges like that we kind of signed up for. Like we started out and wrote all the software in Python because that was the fastest thing to do to get started, and we needed to like run our customers' Python code. But we knew inevitably that was not going to scale, that it was not going to be fast enough, and it has been a Herculean project to rebuild a lot of that software in C++ and Rust. And it would have been simpler to start there, but then we wouldn't have known whether anyone cared. Like basically, if you run it fast C++ for no reason, it doesn't help anyone.
There was a great quote that one of my early mentors had shared with me a couple of times where it was all about it doesn't matter if you do that in the perfect way because you have a need to have it actually deliver value to your customers, which if you don't have is certainly a challenge. Yeah. I would have personally avoided Python, but if you're in the machine learning realm and it's 2022, that's pretty much the only interface around and what people are trying to use to get running. And if you had started with Rust at that point, it would have been way too early on, I think, to actually have the infrastructure available. But in the space going for performance, and we see a lot of the database engines being rewritten in Rust now, which I can definitely see if you're closer on the database side, that makes a lot of sense.
Yeah, and so also it turns out that, to my surprise, honestly, the interop between both Rust and C++ and Python is really fantastic. So it's been fairly achievable to kind of rip pieces out and rebuild them in the faster language. Definitely would have been a lot simpler to start there.
Did you have Rust experience before going in here? Or was that like, we'd have to learn that's because...
Right. Yeah, very little. And I think that's actually one of the things that's pushed us more towards C++, although originally we thought we'd be a Rust company, because there's just so many things that are going wrong every day, that you don't want to add on the extra layer of, I don't even know my programming language. So again, it's like if I had known Rust at the very start of the company really well and been an expert, I would have just started there. But for lots of reasons, C++ was a better intermediate for us from Python. I'd say aside from the complexity of the language or the familiarity, turns out a lot of database drivers are actually like natively implemented in C++. So if you want like the full suite of interfaces to things like, DynamoDB or whatever, you don't get that through the Python interface, and maybe the Rust driver doesn't even exist.
You're integrating with the databases that exist through their APIs directly rather than utilizing, say, the AWS SDK for doing that?
That's right, yeah. I mean, it turns out like the AWS SDK uses an old version of libcurl, and it's really slow. So if you want like really fast access to most of the AWS data stores, it makes sense to build your own just HTTP connection to them.
I think a lot of people either just cringed or got really excited that you said that because now they have a new thing that they can spend all their time doing. I can make my application faster by getting rid of the AWS SDK and replacing it with one that I wrote myself.
A lot of this company has been about that exact kind of intuition breaking. Like I'm a library maximalist. Like I always start with the library and I'm like, surely this must work. But it turns out that if you are trying to count microseconds, a lot of times the library is written with different constraints. Like maybe the author wanted to auto-generate it, or maybe they wanted to have, really nice error messages or something. They have some other concerns. But if literally all you care about is, okay, I have to make this happen in less than 2 milliseconds, and at a high throughput, weird stuff starts to creep in, and you have to develop opinions about a lot of layers of the stack.
And I'm going to get this wrong because it's been way too long. I'm starting to recall a video about getting rid of all of the solid principles on software development. So the set of solid, which are like single responsibility principle, open closed, GAO substitution principle, whatever. YouTube video creator basically goes through each one of them and be like, why is it a mistake from a performance standpoint? Like, did we write better software by following these? And like, it's like, well, no, actually we wrote worse software. It's more confusing, but even worse, if you look at the performance, it's not a factor of 2 or a factor of 3 or even 10 where you're like, oh, we'll just ignore it for the most part because we have a set of 10 items or even 100 items. But you have a set of 1,000 or 1,000,000 and it really makes an impact there. I mean, it's a good point because we saw this early on with especially with JavaScript in AWS, the library was managed manually, and then I think it was like 5 years ago, they switched to AWS SDK version 3, where they were using Smithy to generate all their SDKs now. And I think it's gotten significantly worse, not necessarily from a performance standpoint, but definitely from a usability one. And it's okay if you're a massive platform where people are like, we'll do whatever we have to make it work. And there is consistency across languages. It's just not that great. Like if you know your language really well, you know Python really well, you know JavaScript, and you go to use the SDK, it's like nothing you've ever used before. Yep. But now you're saying also, security aside, because AWS is great at that, performance-wise, it could be a concern. Like that didn't really ever occur to me. Like unless you're interacting with like Valkey or RDS, MySQL, Aurora, there's custom SDKs. Like you were not using the AWS one, but if you're using one of the serverless options, you are probably using the SDK. So that's really surprising, actually.
Yeah, no, I mean, actually, Valkey is a great example of where we had to spend a lot of time thinking about stuff because, like, for one of our customers, we're pushing back and forth gigabytes a second of floats, basically. So we had to think about the encoding, the connection pooling policies, the retry policies for intermittent failures, all of those details. And when there's like 2 or 3 layers of SDK and abstraction in the way, it really messes with your ability to reason about the system in like the intense scenarios. It like works fine on day 1, but it's just, on day 90, you're regretting not understanding how this stuff works.
You've mentioned that there's quite a few of those lessons that you've learned. Like, does this conversation just go on for hours with all those lessons learned? There's like, another one that just like immediately pops out at you.
Well, I mean, another one is probably like, I originally assumed that Python was not that slow. So, it has like async, you're like, cool, I can use it to do parallelism. How slow could adding numbers together be? Like, I have a lot of experience writing JavaScript and like, it's an interpreted language, sort of, like obviously the JIT's incredible. But if you do a for loop and some integers, it'll not be that much slower than writing the equivalent program in C, right? But those feelings don't really hold true for Python. It's really easy to end up with function calls or like trivial operations taking single digit or tens of microseconds because of all the indirection and interpreter overhead and the absence of a JIT. And if you're trying to do something, billions or trillions of times and it takes tens of micros, all of a sudden you're looking at like real seconds adding up, which makes entire categories of operations impossible. So obviously we wrote a lot of software out of C++ and Rust, but we also try to transpile effectively our customer software out of Python into an abstract expression representation.
Wow.
So that's a whole thing too. So we let people write transformations over data. And maybe one of the weird twists is that they want to write those transformations in Python when they run on our platform, as opposed to standard SQL. So what we do is we run this thing, which is effectively a symbolic interpreter. It has roots in Google's type checker, which they just sunset had. But we basically evaluate all of their functions symbolically. So instead of actually executing them, we model the control flow and try to do little proofs about nullity and non-zeroness and positive and negativeness of integers and things like that to prove we understand the semantics of it. And if we can prove that we fully understand a function and all the associated functions it calls, then we don't need Python to run it. We can basically interpret it into a different DSL for executing expressions. And then we can run, A plus B from Python, or even for loops or conditionals or like some library code entirely Python free.
This is normally used for semantic validation of code for ensuring that the outputs, especially in the financial domain, are like reasonable. And I think a good corollary here is if you have a add function, you're not literally going to pass in every possible integer value or float value into both parameters and then validate the output. It's just not possible. So instead you write your programming language or your tree in a way that is verifiable, and then you verify it. But you're using it to actually then port it over and do not only interoperability, but actually runtime execution in whatever engine you want. Are you then running it in Rust or C++ at that point?
Yeah, so the underlying execution engine for us is Velox, which is what Facebook uses to accelerate Presto, which is their internal analytical database. People are also using it to accelerate Spark. It's called Gluten. That is implemented in C++. A lot of the operations are either GPU accelerated or SIMD accelerated, so like down in the assembly code. But yeah, it's exactly what you said. The point is if you understand what a function does, you don't need to literally run it with the original programming language it was written in. And then for us, the game becomes, making sure we're perfectly sound, because if we're going to take your Python and like not run Python, we better be really sure we understand exactly what that's doing. And that is tricky in the presence of a lot of Python constructs. Like if people are using, like if conditionals to implicitly check nullity, but also like non-falsiness. We have to represent all the semantics. So it ends up being kind of like a type checker. And we do a lot of the stuff that like Liquid Haskell does. to trap not just like coarse categories of types, but also the values within the types. So we can prove that like array indexes are inbounds for a list, so that we know that like indexing a list by some integer value I never throws an index error or something like that.
Because you already know the length of the array fundamentally at equivalently compile time of the code. Yeah.
Yeah, we track like, oh, we know it's a constant list and we know the index is less than the constant length of the list, et cetera, that sort of stuff.
You've got a future and so many technology directions here, because not just interacting with the database, but like unit testing or code validation, semantic validation. There's another one here that I'm not thinking of at the moment, but like just you can just easily go down any of these paths as added value for your customers in a way.
Yeah, that's right. I mean, I think like we have an LSP plugin. I mean, it's incredibly slow right now, so no one uses it. But we're working on making it faster.
That's the reason no one's using it, because it's slow.
It's like takes 45 seconds to type check right now. But basically the intent, and I'm told that we'll have this fixed soon, is that like as you're typing in your editor, we'll be able to tell you whether or not we can transpile the program or not. But also we can tell you, oops, you've made a mistake, because we know that you've like, done a null pointer error. So we can let you know that right there in the editor. And then the next thing we're going to start doing is actually taking the historical values that this function would have been computed on. Like we know all the values of all the inputs to the function like statically. So we can tell you like, as you're typing, what the output distribution of your function would be, which I think is an interesting thing for data engineers, because, if your function only produces 0, it's probably not a very useful function.
Is this something that you've developed for your company that is proprietary internal, or something you've open sourced?
Yeah, it's proprietary right now. We did a presentation on how it works at VLuxCon. There's an open question about exactly how much of this will upstream, but probably not none of it.
The question came to me because I do remember someone asking a number of years ago, like, hey, it wasn't linear algebra, like calculating the solution set, but it was similar to like, hey, I'm just sort of curious for these variables that are parameters in my function, what values input and output make sense. Yeah. And it sounds a lot like that. Like, oh yeah, the output bounds are, here's the distribution. We know it's always going to be between 0 and 1, or 0 and, max int or whatever, guaranteed, never negative. And I think there is something to be said about the value there. I do worry that in today's world, there's more and more companies that are trying to go faster and sacrificing quality and caring about that. Is that just my network, or, do you see something similar?
Yeah, well, I mean, it's actually a big support challenge for us. I mean, every customer we have wants to use Cursor or Cloud Code to generate all the integration code with us. And it turns out Cursor and Cloud Code have a lot of great ideas for functionality we should build but have not yet. And suddenly it becomes a customer relationship issue for us, that they're generating code without verifying that it even matches anything we've ever claimed to support. I feel that really acutely right now. People are moving very fast.
Ajima Palumi, 2 episodes ago, told me that they used that to determine originally some features they should build.
Yes.
Because which look, I already don't like that we're changing humanity to figure out how to talk to the LLMs rather than improving the LLMs to understand, us individually. But now we're also letting the LLMs decide which features we should have, just because they're continuing to lie to our customers about having that feature, even if it doesn't necessarily make sense.
Yes. I think that we are starting to evaluate all of the DSLs and things like that we expose by like, does this work with Cursor or not? So it's definitely a new kind of dynamic in that product management.
Would it make sense to take obviously you're a small team in a small company, still startup, 3 years old. You have the whole runway in front of you, basically, of whether or not it's going to be successful. So This is probably incredibly irresponsible of me to ask. But it does seem like there's another product here where you can absolutely use your engine, building the ASTs, to validate the semantic correctness of the programs that the LLMs are generating. And I don't think anyone is doing this effectively right now.
Yeah, that's definitely something even just for my own sanity, we need to start doing, because I can't keep answering questions about the hallucinated code for the rest of my life. But I think that kind of the original inspiration, part of the inspiration for the company dates back to, I can't remember the name of the editor, but there was that Kickstarter editor about 10 years ago where someone wanted to, or it's called Light Table, where basically people were like, let's reimagine what an IDE could be. I think a lot of the ideas in there were fascinating. Like, okay, what if functions were entries in a database instead of like lines in a file? What if we did track all the inputs and outputs to functions in production, so we could show you like what the distributions were, but also if you make a bug, we can tell you immediately that you're about to ship a bug to production. I do want to get back into the core thesis of Chalk was that we could provide really good data developer experience for data engineers. And I do want to get back into the nuts and bolts of like working on those sorts of problems rather than just, fixing TCP congestion issues.
Admirable, definitely. I approve. I approve on solving the technical problems. I mean, because I feel like in my career, it definitely started out as this lie we tell ourselves, like we do software development to solve challenging problems. And I think we just say that because that was our education experience where we were forced to solve challenging problems and then we got credit for it and created this positive feedback loop. And we thought that's our personal identity. And then we go out into the workforce and we keep on repeating that. And then we learn after some time that we don't get rewarded or promoted for solving technically challenging problems. And so we get away from that. And then we have this lie that it transformed into, it's all about talking about our successes, et cetera. Although I think at this point, I'm starting to realize that the original thing isn't such a lie. Like at a company level, if you build a great technical solution that solves a real technical problem, that it will get picked up and start being used. And the better job you do at it, the more people that will flock to it. Because as you said, you won't have any churn. You literally are the only ones that build this thing and are the best at building it. Everyone will come and start using it. And that makes me a little bit happier than believing that, some company out there is just going to replicate every single SaaS product that will ever exist as if it's going to work. Yeah, sure. It may look like it works, but I don't think it's going to actually work until they have Chalk's newly open sourced. I shouldn't say that because it's not open source yet. Would be open sourced, some part of it, AST validator.
Yeah, one day we'll be able to prove all software is correct and solve the halting problem, but not today, unfortunately.
That's not a solvable problem, actually. And there's a great Veritasia video about the hole at the bottom of math, but that's not going to be my pick for this episode. So before we get to picks, I'll ask Andrew, is there anything else about Chalk or about LLMs or about immutable data structures, Python interpretability that you want to share with our listeners?
Oh, immutable data structures. I mean, I feel like they're a constant siren. You always want to use an immutable data structure when you are, working in your software because it's got all the properties you want, right? Like you can't mutate it, so you can avoid the thread safety issues, et cetera, et cetera, et cetera. But they're just always so slow. So we've always had to rip them out.
I would never have guessed that. I mean, I could imagine that you were a huge fan of like Haskell. Then
I don't have my Haskell book on my desk right now. I think way back in high school, like senior year of high school, I found Learn You a Haskell on the internet or something like that, and it absolutely blew my mind. But it's the same lie that Haskell has to tell. Like it presents an immutable interface, but under the hood is mutable data structures, and we're under the hood, unfortunately.
My problem with functional programming was that everyone who tried to convince me that functional programming was the best thing ever always had the same message, which is functional programming is the best thing ever. There's like monads and immutability, and that never sold me, honestly, and I never got there. And after years and years of software development, I came to the realization that there's a much better marketing sales pitch for these languages, especially things like Rust or Haskell, where you can actually look at a function and know that you've handled every edge case. And you don't, and like that for me, like this was always something I was like, I hate Java, but I appreciate Java because it captures the exceptions as part of the function signature. And until I realized that functional programming is actually baked this notion in by default into the language, it never really connected with me. But if anyone had ever said, aren't you worried that you're missing some edge cases? And I'd be like, yeah, I am totally worried. Then I would have started with Rust much sooner. I would have switched to F# probably earlier in my career. And I think I would be happier for it. So people who say, Haskell is great for like rule engines and stuff like that, whatever. But yeah, this edge case and what we talked here about the ASTs, I think is a really good justification to spend time to switch out and try some of these alternative solutions.
Yeah, definitely. I mean, check errors in Rust have made so many categories of bugs not happen. I sleep a lot better at night.
I early on in our company started categorizing every single possible bug that we ever saw in production or caught and didn't expose in production and like what caused that. And there's a number of bugs that are type related things, which are just like, yes, we had the wrong type or it was too loose or whatever, and we should fix that by switching to something else. But then there's a whole class of things of like, no, it's actually not possible to write the validation in this way, and switching to a different language would have just prevented this from ever happening.
Yeah, absolutely. I mean,
Yeah.
then DNS is down and it didn't matter anyways. It turns out that like DNS in Kubernetes is not really a very reliable thing unless you spend a lot of time thinking about it. So that's been a recurring theme in my life this year.
I'm horrified that you could even say those words, and I'm even more concerned to ask for more details. We're on the cusp of the end of the episode, so if it's quick and concise.
I don't know if networking debugging is ever that quick or concise. But everyone who's using kubedns still maybe stop, but also check your scaling policy. It's probably underscaled in GKE by default.
And this affects DNS how?
If you don't have enough replicas, DNS will start to time out when you try to resolve names. So, I mean, the classic issue is your auto-scaling group says, cool, time to double the pod count. Everyone boots up and tries to resolve, your database IP address. And then they fail to resolve your database IP address. And then unfortunate things happen as a consequence.
Absolutely amazing. Okay, so with that, let's switch over to picks for the episode. Andrew, what did you bring for us today?
Yeah, so I had a serious answer, but I think my silly answer is everyone should get an e-bike. It's a lot of fun. I would recommend getting one of the e-bikes, which looks exactly like a regular road bike, so that when you're going up a hill, all the, really extremely serious cyclists get jealous and you can hear their gears change as you go by. It just goes ka-chunk, ka-chunk, ka-chunk as they all try to catch up.
You've had this experience multiple times.
Yeah, of course. It's my favorite weekend activity.
Is this a newfound hobby of yours, or one that you've been living with since the invention of e-bikes?
Yeah, so I've actually been really into road cycling for a long time, but my wife bought an e-bike recently so that we could kind of keep pace better on rides together. She doesn't want to get super beat up, and I do. But we've been doing that basically every weekend for maybe the past 6 months.
What sort of e-bike do you have?
She has a Trek e-bike. It's like a Trek Damani or something like that, but it looks exactly like a regular road bike, so it passes the stealth check.
Okay. I was racking my brain what to pick today, but since I'm traveling to the US, I decided to bring some Swiss chocolate. And I have to say something about Swiss chocolate. Since I'm originally from the United States, I thought I just always hated chocolate. I have to say that it's because the chocolate is bad, honestly. And if you're ever in Switzerland and you come here and you're like, I want to get some really great chocolate, the number one thing you should not do is go to a famous like chocolate manufacturer or go to a special store that's shrouded in controversy. Instead, just like go to your local grocery store and just grab a random one. It will be absolutely fantastic. So my pick today is actually going to be the grocery store Migros, which is like one of two major grocery stores in Switzerland. And they have a special brand called Frey. And this is like the pistachio version. And it's like, honestly, the best chocolate I've ever had. And it's like, you just go to the store and you just buy it. There's no like special dance you have to do. It's not like a special company or anything. And the interesting thing is like their brand that actually produces this is like totally social conscious and concerned about environmental protection laws and where the cocoa is grown and manufactured and assembled and everything like that. So you can be sure that no corners are being cut there.
Well, I got to move to Switzerland. It's the dream.
The second best time is now.
All right.
So that's it for today's episode. Thank you, Andrew, for coming and joining us and talking through all those really interesting technical challenges that you've had.
Of course. Thanks, Warren. I really appreciate you having me.
Yeah, I mean, this has been a great conversation, and we'll be back again next week.